Today we'll practice calculating slope using both a graph, so we'll calculate it graphically, and using the slope formula, calculating algebraically. We'll be looking at a positive slope, a negative slope, a zero slope, and no slope. So let's start with a positive slope. We'll first start by calculating the slope of this line graphically by using the rise over the run. So we have 2 points. You pick a point, and to go from this point to that point, you rise 1, 2, 3, 4. So you rise 4 and run 1, 2, 2. Well, 4 over 2 can be simplified to 2. So the slope of this line, which we represent with the letter M, is 2. We could have also started with this point and gone to that point. So we start at this point and we fall 1, 2, 3, 4. So our slope is -4 over, and then we run to the left 2, 1, 2, -2. And -4 divided by -2 simplifies to 2. So as you see, it doesn't matter which point we start with, the slope of the line is still 2. So this is calculating the slope using a graph, using rise over run. We're going to take those same 2 points and calculate the slope algebraically using our slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So find the slope of the line that passes through the points below. So when we're using the slope formula and finding the slopes algebraically, we always start by labeling our points. Well, this is an x and a y. We're going to call this one x sub 1 and y sub 1. And our next point we're going to call the x and a y x sub 2, y sub 2. And the numbers 1 and 2 are just labels or names so we can distinguish between the 2 points. So now that we've labeled our points, we're going to substitute it into our slope formula, y2 minus y1 over x2 minus x1. So y2 is 3 minus y1 is a -1, so 3 minus a -1 is 3 plus 1. And for our denominator, we're going to take x2, 0, minus x1, which is -2. So again, minus a -2 is plus 2, and that's our denominator. So now we're going to simplify the top. 3 plus 1 is 4. 0 plus 2 is 2. So we have a slope of 4 over 2, which can be simplified to 2. So as you can see, the slope of this line is 2, no matter if we do it graphically, starting from this point to that point, or from that point to this point, we still get 2. And when we use our slope formula, we get the same number. So let's calculate the slope of a negative line, a line with a negative slope. So here we're going to start graphically again, and when we use the graph, we like to use rise over run. We can start with either point. Let's start with this point, and we're going to go from this point to that point. So we're going to fall 1, 2, 3. So we're going to go down 3, and to the right 2. So -3 over 2 is our slope. We could have also started from the bottom point and rise 1, 2, 3, a positive 3, and run to the left 2, which is -2. So the slope of this line can be written as -3 over 2, 3 over -2, or we could put the negative sign in front, -3 over 2. They all indicate the same thing. So now we're going to take those 2 points and we're going to calculate the slope algebraically using the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So to begin with, anytime we use the slope formula, we're going to label our points. So x sub 1, y sub 1, x sub 2, y sub 2. So now we're going to solve using our slope formula. So y2, -1, minus y sub 1 of 2 over x sub 2, 3, minus x sub 1 of 1. So -3 over 2. And that's the same slope we got when we did it graphically using rise over run. Let's calculate a zero slope, a line with a zero slope. This is a horizontal line. All horizontal lines have a slope of 0. Let's calculate the slope of this line using rise over run. So to go from this point to that point, we rise. Well, we didn't rise. It's all levels, so we didn't rise. So we have a rise of 0 and a run of 1, 2, 3, 4, 5. 0 divided by 5 is 0. We could have started with the other point. Again, our rise is 0. But in this case, we went to the left 5. So it's 0 divided by negative 5. 0 divided by negative 5 is still 0. So the slope of this line is 0. And all horizontal lines have a slope of 0. So now let's calculate the slope of this line algebraically using our slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So again, we always label our points first. So we have x sub 1, y sub 1, x sub 2 over y sub 2. So now we're just going to substitute into our formula. Y sub 2 is 3, y sub 1 is 3. 3 minus 3 is our numerator. X sub 2 is 3 minus a negative 2 for our denominator. 3 minus 3 is 0. 3 plus 2 is 5. 0 divided by 5 simplifies to 0. So whether we use our slope formula or a graph, this horizontal line has a slope of 0. We're also now going to finally calculate a line with no slope. So as you see, we have a vertical line. All vertical lines have no slope or an undefined slope. So let's use the rise over run since we're dealing with a graph. We'll start with the top point and go to the bottom. So we fall 1, 2, 3, 4, 5. So we go down 5 and we don't run. So we have 0 in our denominator. Well, anything divided by 0 is undefined, or we call it no slope. Again, we could have started with our bottom point and rose 5, and we'd still run 0, and we'd still get an undefined slope. All vertical lines have a slope that's undefined. So let's do it algebraically using our slope formula. And we will start by labeling our points. X sub 1, y sub 1. X sub 2, y sub 2. So y2, 4 minus a negative 1 over negative 2 minus a negative 2. Remember, when we minus a negative, it's a plus. Gives us 5 over 0, which is undefined, or no slope. All vertical lines have an undefined slope. So to recap, we started with when we're working with a graph, we're going to use a rise over run, and when we are given 2 points, we're going to use our slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We had a positive slope of 2, whether we use the graph or the algebra. We had a negative slope that was negative 3/2, whether we use the graph or the points. We had a 0 slope, which is a horizontal line, and again, both the graph and the algebra indicated it was 0. And when we had this vertical line, the slope is described as being undefined, whether we use the graph or the slope formula.